Hello everyone, welcome to the control system. This is part 6 of lecture 7, Transient and Steady State Response Analysis. And in this section we'll discuss servo system with velocity feedback. And please refer to this chapter for more detailed explanations. Okay? And for the control system, the derivative of the output signal can be used to improve the system performance. And in obtaining the derivative of the output position signal, it is desirable to use tachymeters. Okay? These tachymeters, and instead of physically differentiating the output signals. And this tachymeter is a special DC generator, and it is frequently used to measure the velocity without differentiating the process. Okay? And the output of the tachymeter is proportional to the angular velocity of the motor. So it is desirable to use this tachymeter instead of physically differentiating the output signal directly. Okay? It is important to note that differentiations amplify noise effect. So in fact, if this continuous noise are present, differentiation amplify discontinuous noise more than the useful signal. So the geometer is a good choice. Okay, so let's consider the system below. This is the plan, the system. And from this system, the positions and velocity are fed back. Okay, so this is positions fed back to input to produce actuating errors, and also velocity here also fed back to to here and to produce an actuating error signal. Okay, and this block diagram can then simplify to this. First, you need to simplify this one first, and then combine this one with this one. Okay? And giving these transfer functions, Cs over Os. And comparing the equation 10, the damping ratio psi become this one. And you can see the undamped natural frequency omega n is square root of k over j. And it is not affected by velocity feedbacks. It's not involved kh. And note that the maximum overshoot for the unit step input can be controlled by controlling the value of the damping ratio, this one. And we can reduce the maximum overshoot by adjusting the velocity feedback constant, this kh. Okay, so that this will be in between 0.4 to 0.7. It is important also to remember that the velocity feedback can affect of increasing damping ratio. Okay? So without affecting the undamped natural frequency of the system. Next, consider the impulse input RT. It's an impulse input, and the corresponding Laplace transform is unity or Rs equal 1 for the second order system. And the unit impulse response Cs of the second order system is this one. And then take the inverse Laplace transform of this equation, yield this. For 0 less than or equal to psi less than or equal to 1, you have this one. In case that this psi equal 1, and then you will end up having this Ct, okay, which is in the functions of omega n and t. And in case that xi larger than 1, you will have these equations. For more detail of the explanation, please go to chapter 5 of the book. Okay, thank you.